In order to tell the degree of a polynomial, in other words, and if it is linear, quadratic, cubic, quartic, or quintic, we just need to figure out the finite differences in the x and y values. First, let's check to make sure that the x values are all evenly spaced out. So how far is it between each of those numbers? It looks like it's going up by 1 each time. So the x's are all even, and now let's check the y's. Between 32 and 22, that difference is down 10. If you're wondering how I got that number, you could always do the second number, the 22, minus the 32, and you'd get negative 10. Next, we'll find the difference between 22 and 15. That's down 7. Between 15 and 15, the difference is 0. Between 15 and 24, the difference is 9. And here, the difference is 18. In other words, 42 minus 24. Since that was the first time we did it, and the numbers all were not the same thing, this is not a linear function. So let's do it again. Between negative 10 and 7, it's forward 3. Between negative 7 and 0, it's forward 7. Between 0 and 9, it's up 9. And between 9 and 18, it's up 9. So that was the second time we did it, and we did not get the same number. So let's try it again. Between 3 and 7, that's forward 4. Between 7 and 9, that's forward 2. And between 9 and 9, that's forward 0. That was the third time. We still didn't get the same number every time, so it's not cubic. So one last time. Between 4 and 2, that's down 2, and between 2 and 0, that's down 2. Since this was the fourth try, number 1 will be quartic or fourth degree. We don't need to find the equation, we just have to find the degree. When you try B, you'll find all the differences, and the answer for that one, you should get the same number on the third try, and that one will be cubic. Now we do want to actually find the equation for the model. When we look at this table, on the calculator, we will go to the list on Stat and Edit, and we'll put the years in L1 and the population in L2. Now, since this is a year, rather than starting at the number 1960 for the year 1960, let's just make 1960 the very beginning, and we'll call it year 0, because that's where we're starting before any time has gone by. Which means that the year 1970 would be 10 years later, 1980 is 20 years after 1960, and then 30 years, and then 40 years later. That way, when you look at the numbers on the calculator, they'll be a little easier to work with. If we start off with using those thousands, the numbers just get so big that it's kind of a pain to write down. So we'll put 10, 20, 30, 40 in L1. We'll put the bottom row numbers in L2, and then we'll do Stat over to Calc, and then you can try the different types of regression. If you get linear and quadratic, you'll notice that your r-squared values are okay, but when you go to do cubic, which is what's on the screen right here, you'll notice that your r-squared value is 0.9999999. That's a pretty good one. So we'll go ahead and use cubic. What we're going to do is we're going to write this equation right here, but we're going to substitute each of those letters, A, B, C, and D, with these numbers right here, and we're just going to round them. So instead of 104.58, let's just round that up to 105. So our equation will be y equals 105, and that's next to x to the third. The next one, b, is negative. Let's round it up to minus 284, x to the second. C, let's leave it 1098, it's positive, so we'll put plus 1098x. And the constant will round to 4263. And that's it. Example 3, hopefully you're going to put in your calculator, we'll put the years in L1, the prices in L2. So you're going to need to go back to your lists, press the up button, and then clear enter so that they all clear out. And for this problem, instead of starting with 1994, we'll start with 0, and then 1 year later is 95, 2 years later, 3, 4, and 5. So put 0 through 5 in L1, put those prices in L2, and then when you press zoom 9, you should see something that looks like this graph right here. Now, I'm going to draw a couple lines through it that aren't going to make sense. Would it make sense to make a linear correlation through these? Well, no, because we can see that these dots are kind of going up and then back down again. So I'm going to go ahead and skip through quadratic, because they're not really a U shape, because that one kind of looks like it's going back up. Cubic, it's kind of cubic. You could try them. It would tell you the R squared value. The best one that you'll get is going to be quartic. And you can sort of see, kind of looks like that W. So when you run the quartic regression, option 7, you will get an equation that I don't have in front of me. I kind of left it at school, but it's the one with the x to the 4th in it. And now I'm trying to remember the answer to the prediction without my calculator in front of me. What you would do to get the prediction, once you had the quartic equation in your calculator, is you would go to the table and figure out when the year 2000 is. So the year 2000 would be the next one over in the table, which means that it would be next to x equals 6. So you would just look in the table for the value that was right here for y, and that would be the answer to your prediction in dollars. Remember to get to the table at second graph. You can use your calculator sheet, so have that handy, and good luck.